Welcome back, everyone. Let's jump right into today's explainer, because we're looking at something that's practically guaranteed to take your B4X user interfaces from those standard flat layouts into something completely dynamic. We're talking about the B4X Daisy Tag Sphere, an incredibly cool custom view that brings 3D components straight to your apps. Check this out. This is the exact end result we'll be breaking down today. We're not just looking at a boring text list. We're talking beautifully spinning interactive 3D avatars and custom icons literally suspended in virtual space. It's fluid, it's interactive, and honestly, it's surprisingly accessible to build. So here's our game plan for this explainer. We'll introduce the B4X Daisy Tag Sphere, check out a visual showcase, cover the basic configuration, dive into the 3D projection math, and wrap up with advanced draw tag customization. Let's get to it.
All right, part 1, introducing B4X Daisy Tag Sphere, your go-to for dynamic 3D tag clouds in B4X.
Now, whether you're targeting Android with B4A, iOS with B4I, or desktop with B4J, this component is wildly versatile. Look over here. You've got circular avatars and custom target icons just floating in space. But then, completely shift gears, and you've got this playful, interactive cluster of emojis that you can actually control with real-time UI sliders to tweak the radius and sensitivity. You're definitely not locked into one single look. It easily adapts to whatever vibe your app is going for.
But you're probably wondering, how does it handle scale? Well, the density is where it really shines. You can have a super clean classic word cloud with, say, 20 tech tags like React and Python. But then you can crank it up to a massive, dense sphere made of 250 individually rendered, custom-drawn dots. And the internal engine, it handles that heavy load like a champ, maintaining a buttery smooth 60 frames per second.
Okay, so seeing all this visual candy naturally begs the question, right? How do we actually bring this 3D sphere into our own B4X projects? Is the code going to be a total nightmare?
Well, let's look at part 2, basic setup and configuration, starting with the designer properties. You'll be glad to know that spawning this sphere just takes 3 super simple steps. Step 1, you initialize it, passing the callback module and an event name so it knows where to route user interactions. Step 2, you use add to parent to snap it into your layout and set the boundaries. And step 3, this is the easy part, you just call set items and hand it a list of strings. That is literally it. 3 lines of code and boom, you've got a rotating 3D cloud.
And it gets better, because you have all these powerful designer properties right out of the box to control the physics and the visuals. You can tweak the radius to pack your items tightly or spread them way out. You can play with touch sensitivity to dictate how fast it spins when a user swipes. Auto-rotate keeps the whole thing alive and drifting when idle, and easing manages how those tags fade out as they drift to the back of the sphere. You get all this granular control, and you don't have to write a single algorithm yourself.
Which brings us to part 3, the magic of 3D math and understanding the core engine behind it all.
It all starts with one fundamental data structure, the tag point. Every single item in your sphere gets one of these. It holds X, Y, and most importantly, Z coordinates as floats. X and Y handle where the item sits on the screen, but that Z coordinate, that's the secret sauce right there. That Z value is constantly tracking how deep into the virtual screen that item is sitting at any given moment.
But here's the catch. Our device screens are totally flat, right? They're 2D. So we have to flatten that 3D tag point. This is where the Project X math equation comes into play. The engine takes the projection distance, multiplies it by the X coordinate, and divides it by the radius minus that Z depth coordinate for centering it. It's classic 3D projection math, creating that perspective distortion that totally tricks your brain into seeing a flat canvas as a deep 3D space. Math alone won't save you, though. I mean, if a tag in the back suddenly draws over a tag in the front, the illusion is completely shattered. So we use Z-sorting. The component relies on an internal Z-sort indices function, basically pulling off the painter's algorithm. It sorts every single tag based on its Z coordinate, every single frame. That guarantees the tags in the foreground are always drawn last, perfectly hiding whatever's rotating into the background. And to really sell that 3D effect, we need depth alpha easing. Just look at the difference here. If you use none, every tag renders at a solid 255 opacity, no matter its depth. It just ends up looking flat and cluttered. But apply an easing curve based on that depth, the t.z value, and the component calculates a smooth fade. Tags way in the back dynamically drop down to an alpha of 30, while front tags pop at a solid 255. It creates a dramatically stronger, much more atmospheric sense of depth.
All right, moving into our final section, advanced customization and mastering the draw tag event. Notice how complex these structures are? They aren't just standard text or basic images. These spheres, like the dense cluster of 250 colored dots or those intricate circular ring icons, they're generated entirely frame by frame via code. The component is basically handing you the paintbrush. So how does that work? It's all in the draw tag event. When you turn on custom drawing, the component fires this event for every single tag, every single frame. It passes you a map with everything you need: the B4X canvas to draw on, the precise X and Y screen coordinates, the alpha opacity based on its depth, and the item's index. You just take those parameters and draw whatever your heart desires right onto the canvas.
Now here's a super interesting technical nugget. Why are all 5 of those variables shoved into a single map object instead of just being passed separately? Well, it's actually a really clever workaround for a limitation in B4X. See, B4X dynamic event dispatching using the call sub2 function maxes out at 3 arguments. Because we absolutely need to pass 5 distinct pieces of data, the component packs them into one single map structure. It bypasses the limit entirely and keeps the code super clean. But hey, visuals are only half the battle. Users actually have to interact with this stuff, right? Thankfully, the component handles native interaction events beautifully. When a user taps the screen, it runs a 3D hit test. And thanks to that Z-sorting we talked about, it accurately grabs the frontmost tag, completely ignoring anything hiding behind it, and fires off either a tag tap or tag long press event, returning the exact string of what was touched. You can use that to trigger navigation, open menus, you name it. We've covered how to initialize it, dug into the 3D math under the hood, and unlocked the absolute power of frame-by-frame custom drawing. You've now got a rock-solid understanding of how to implement B4X Daisy Tag Sphere. So I'll leave you with this. Now that you aren't stuck with flat lists and static grids, what are you going to build with infinite 3D canvas customization? The possibilities really are endless. Thanks for hanging out with me for this explainer, and I'll catch you next time.